हॅलो स्टुडंट्स, काल आपण ॲडसॉर्प्शन अँड कोलाइड्स या टॉपिकमधला ॲडसॉर्प्शन आणि ॲब्सॉर्बंट हे कन्सेप्ट बघितले. त्याचबरोबर सॉर्प्शन, डिसॉर्प्शन. आज आपण बघणार आहोत टाईप्स ऑफ ॲडसॉर्प्शन अँड फॅक्टर्स अफेक्टिंग ॲडसॉर्प्शन. फर्स्ट वी आर गोइंग टू सी द टाईप्स ऑफ ॲडसॉर्प्शन. Types of adsorption. There are two types of the adsorption: physical adsorption and chemical adsorption. Physical adsorption is also called as physisorption, and second type is the chemical adsorption. Chemical adsorption, which is also called as the chemisorption. These are the two types of the adsorption. Then what is the difference between the chemical adsorption and the physical adsorption? Or physical adsorption means when there is a weak van der Waals forces between adsorbent and adsorbate. ॲडसॉर्बंट म्हणजे ज्याच्यावर ते ॲडसॉर्प्शन होत असतं तो ॲडसॉर्बंट. ॲडसॉर्बेट म्हणजे ज्याचं ॲडसॉर्प्शन होत असतं तो ॲडसॉर्बेट. फॉर एक्झाम्पल, दिस इज द चारकोल अँड द गॅस इज ॲडसॉर्ब्ड ऑन दिस चारकोल. देन दिस इज अ ॲडसॉर्बंट अँड दिस इज अ ॲडसॉर्बेट. इफ देअर इज ओनली वीक van der Waals forces between this adsorbate and adsorbent, then that adsorption is called as the physical adsorption. The adsorbate molecules are accumulated on the adsorbent due to only weak physical van der Waals forces. Such adsorption is called as physical adsorption or physisorption. And if there is a chemical bond between adsorbent and adsorbate, or adsorbate is adsorbed on the surface of the adsorbent due to the chemical bond, either covalent bond or the ionic bond, that adsorption is called as the chemisorption or chemical adsorption. Means hence only there is a physical attraction between the adsorbent and adsorption, that is the physisorption. And when there is a chemical bond between the adsorbent and adsorbate, then there is a chemical adsorption or the chemisorption. The difference between the chemisorption and the physisorption. आता या दोघांमध्ये काय डिफरन्स आहे? फिजिसॉर्प्शन, पहिला डिफरन्स तर आपण डेफिनेशन वरूनच सांगू शकतो की देयर इज अ वीक van der Waals forces between the adsorbate and the adsorbent. adsorbate and adsorbent मध्ये असणारे फोर्सेस कसे आहेत? वीक van der Waals फोर्सेस आहेत. and there is a formation of chemical bond between adsorbent and adsorbate. adsorbent आणि adsorbate मध्ये काय असतो? केमिकल बॉन्ड असतो. As we know, the adsorption is an exothermic process. Adsorption मध्ये heat evolve होते. In physical adsorption, heat evolved is low, or which is called as the low heat of adsorption. Low heat of adsorption. That is, heat evolved during the process of this physical type of adsorption is about 20 to 40 kilojoule per mole. And in case of chemical adsorption, heat of adsorption, that is the heat evolved during adsorption, is a higher. It is about high heat of adsorption, it is about 40 to 200 kilojoule per mole. There are weak forces, there is a chemical bond between adsorbent and adsorbate. Heat of adsorption is low, heat of adsorption is high. As there is only weak forces This physical adsorption is also relatively weak. Forces are weak. This adsorption is also relatively weak. And this chemical adsorption is relatively strong. केमिकल ॲडसॉर्प्शन मध्ये केमिकल बॉन्ड तयार होत असल्यामुळं केमिकल ॲडसॉर्प्शन हे कसं असतं रिलेटिव्हली स्ट्रॉंग असतं. आज हे 3 पॉईंट बघितले आपण पुढचे पॉईंट बघूतील. As there is a formation of the only physical attraction between the adsorbent and adsorbate, the number of adsorbate molecule can accumulate on the surface of the adsorbent. तिथं फक्त फिजिकल अट्रॅक्शन आहे त्यामुळं ॲडसॉर्बेट मोलेक्युलचे लेयर ॲडसॉर्बंट वरती तयार होऊ शकतात कारण तिथं केमिकल बॉन्ड नाही फक्त काय आहे ॲक्युम्युलेशन होणार आहे आणि फिजिकल अट्रॅक्शन आहे. Therefore, there is a formation of the multi-layer of adsorbate on the surface of the adsorbent. Formation of multi-layer of adsorbate on the surface of adsorbent. And in case of chemical bond, as chemisorption, as there is a formation of the chemical bond between the adsorbent and adsorbate, there is a formation of only monolayer, single layer between the adsorbent and the adsorbate molecules. This is adsorbent and this is adsorbate. There is a formation of the monolayer. As physical adsorption, it is only weak process that adsorbed molecule can be resorbed. Adsorbed molecule can be removed from the adsorbent by heating and hence it is a reversible process. Physical adsorption is reversible process. And in case of chemical adsorption, as there is a chemical bond between the adsorbent and adsorbate, it cannot be reversed. Thus, it is a irreversible. Chemical adsorption is irreversible and physical adsorption is a reversible. Then, physical adsorption is not specific. Physical adsorption is not specific, means any gas can be adsorbed on the adsorbent. कुठलाही गॅस चारकोल वरती किंवा adsorbent वरती adsorb होऊ शकतो. All gases adsorb on the surface of the charcoal because there is only a weak forces. And but chemical adsorption or chemisorption is a highly specific. Only specific gases can adsorb on that particular adsorbent. Why? Because there is a formation of the chemical bond between the adsorbent and adsorbate. This is the adsorption of the oxygen on tungsten is an example of chemical adsorption, as well as adsorption of hydrogen gas on nickel catalyst is also example of the chemical adsorption. These are the differentiating points between the physical adsorption and the chemical adsorption. Then the factors affecting adsorption. There are some factors which affects affecting adsorption. The factors which affects the adsorption, first factor is the nature of adsorbent. Adsorbent means the substance on which another substance get adsorbed. ज्याच्या सरफेसवरती दुसरा सबस्टन्स ॲडसॉर्ब होतो म्हणजे तो असतो कोण ॲडसॉर्बंट. मेनली ॲक्टिवेटेड चारकोल ॲक्ट ॲज ॲडसॉर्बंट ऑर द फाईनली डिवायडेड मेटल्स ॲक्ट ॲज अ ॲडसॉर्बंट. देन फाईनली डिवायडेड म्हणजे त्याचा बारीक चुरा केलेला मेटल्स. द लार्जर दी सरफेस एरिया मोर इज द ॲडसॉर्प्शन. ॲडसॉर्प्शन हे सरफेसवरतीच होत असतं त्यामुळं सरफेस एरिया जेवढा जास्त असेल. आता याच्यामधला हा छोटा चॉक आहे हा मोठा चॉक आहे. छोटा चॉकला सरफेस एरिया कमी आहे मोठ्या चॉकला सरफेस एरिया जास्त आहे म्हणजे मोठ्या चॉकवरती ॲडसॉर्प्शन काय होणार आहे जास्त होणार आहे. लार्जर दी सरफेस एरिया मोर इज द ॲडसॉर्प्शन. सरफेस एरिया जेवढा जास्त तेवढं ॲडसॉर्प्शन जास्त असणार आहे. अँड हेन्स चारकोल विच हॅज पोरस नेचर ऑल्सो. पोरस नेचर असेल तर त्याचं ॲडसॉर्प्शनची कॅपॅसिटी काय असते जास्त असते. आणि फाईनली डिवायडेड जेवढे तुकडे जास्त केले जातील तेवढा त्याचा सरफेस एरिया जास्त असणार आहे. देअरफॉर ऑर रफ सरफेस एरिया जेवढा सरफेस एरिया रफ असेल खचखळी असतील तेवढा त्याचा ॲडसॉर्प्शन काय असणार आहे जास्त असणार आहे. मीन्स फाईनली डिवायडेड कॅटॅलिस्ट ॲक्ट ॲज ए गुड ॲडसॉर्बंट ॲज वेल ॲज चारकोल इज ऑल्सो ॲक्ट ॲज ए गुड adsorbent means more the surface area more is the adsorption. This is the first, that is the nature of adsorbent. Larger the surface area greater is the adsorption. Second, nature of adsorbate. Nature of adsorbate. Mainly gases are act as a adsorbate. Adsorbate means the substance which get adsorbed on the surface of the adsorbent. The gases with higher critical temperature, high critical temperature, high boiling point, त्यांचा boiling point जास्त आहे, and which are easily liquefied or easily liquefiable gases are easily adsorbed on the surface of the adsorbent. Gases having high critical temperature, high boiling point, and which are easily liquefiable or which can easily liquefy are easily get adsorbed on the surface of the adsorbent. Thus, the gases like SO2, Cl2, NH3, sulfur dioxide, chlorine, ammonia, which are easily liquefied and hence which are easily get adsorbed on the surface of the adsorbent, then the gas like the N2, O2, H2, nitrogen, oxygen, hydrogen, which cannot easily liquefy. यांचं liquefaction easy होत नाही त्यामुळं कंपॅरेटिव्हली यांचं लिक्विफिकेशन जास्त होतं आणि हे इझिली ॲडसॉर्ब होतात. मीन्स हायली लिक्विफाईड गॅसेस कॅन बी इझिली ॲडसॉर्ब ऑन द ॲडसॉर्बेंट. देन नेक्स्ट इज द टेम्परेचर. ॲज adsorption is exothermic process, that means heat is evolved during the process of adsorption and hence according to Le-Chatelier principle, as in this process heat is evolved, this process will occur or favor at low temperature. The adsorption process will favor at low temperature because this is an exothermic process. ही एक्झोथर्मिक प्रोसेस असल्यामुळं ली-चाटलियर प्रिन्सिपल प्रमाणे जेवढं टेम्परेचर कमी तेवढं ॲडसॉर्प्शनचा रेट जास्त. मीन्स लोअर द टेम्परेचर मोर इज द ॲडसॉर्प्शन. दॅट इज देर इज इनवर्स प्रपोर्शन बिटवीन दी टेम्परेचर अँड प्रेशर. इन शॉर्ट ॲडसॉर्प्शन इज फेवर्स ॲट लो टेम्परेचर. अँड द नेक्स्ट पॉईंट इज द प्रेशर. Pressure that means the pressure of adsorbate gas pressure, adsorbate pressure. If this is a adsorbent and here is a gas which is act as a adsorbate. If more is the pressure on this gas, more is the adsorbent. But initially या गॅसवरती जेवढं जास्त प्रेशर असेल तेवढं ॲडसॉर्प्शन काय असणार आहे, जास्त असणार आहे. पण इफ ऑल द सरफेस एरिया इज फुलफिल्ड बाय दिस ॲडसॉर्ब्ड मटेरियल, तो संपूर्ण सरफेस एरिया या ॲडसॉर्बेटनं फुलफिल झाला तर एक वेळ अशी येणार आहे, देयर इज अ सॅच्युरेशन, all the surface area is covered with these adsorbent molecules and there is no effect of pressure on the adsorption. Nantar if pressure increased, rate of adsorption does not increases. सुरुवातीला प्रेशर वाढवलं, ॲडसॉर्प्शन नव्हतं तेव्हा काय झालं, ॲडसॉर्प्शनचा रेट वाढला. पण एक वेळ अशी आली की सर्व सरफेस एरिया कव्हर झाला ॲडसॉर्बेट मोलेक्युलमुळं, तिथं आता जागाच उरली नाही ॲडसॉर्ब होण्यासाठी. नंतर वरून कितीही प्रेशर वाढवलं तरी ॲडसॉर्प्शनचा रेट वाढत नाही. मीन्स इनिशियली एक्सटेंट ऑफ ॲडसॉर्प्शन ऑफ गॅस ऑन सॉलिड ॲडसॉर्बंट at constant temperature increases with increase in pressure. Extent of adsorption is directly proportional to the pressure of gas but only initially. At high pressure, extent of adsorption becomes independent of the pressure because the surface of adsorbent is then almost fully covered by the gaseous molecules. This can be explained with the help of a graph, that is, if we plot the graph of pressure versus the rate of adsorption. Initially, as pressure increases, rate of adsorption is also increases. But when the surface area get completely full, then as pressure increases, then also adsorption remains constant. This is the effect of pressure. These are the factors affecting the rate of adsorption or the adsorption. And in next lecture, we will see the applications of the adsorption and the catalysis. Okay.